Porter explains that numbers can gain power from authority from being used, especially by institutions that have power. Clarity and parsimony, the tendency to conserve resources, are both aspects that lead to data being useful. They generate legible messages and wide application. This usefulness of numbers leads to a process introduced by Noor Satina in 1999 and expanded upon by Kalthoff in 2005, in which the ways numbers are collected and presented become accepted as normal and certain through repeated use. Porter goes on to emphasize that if a certain number is plausible, sufficient backing and use by an institution of power can make it real. I'd like to look at how aesthetics influence the messages that numbers give us. Let's take an example from the launch of the Space Shuttle Challenger in 1986. The shuttle was set to launch but kept getting delayed because of cold weather. It was costing a lot of money, but the engineers insisted it was not safe. There was a component of the shuttle, the O-rings, that did not hold up in cold weather. To prove it, they gave a presentation to the board which included this graphic. It's visually attractive. It's fun that they use little rockets. The pattern patches on the rocket represent different types of O-ring failure, and you can see the temperature along the top of the rockets. The information is pulled by meaningless organization and useless ink so far outside a recognizable pattern that the data becomes meaningless. This figure has no clarity or parsimony. It was not useful, skipped right over in the discussion. It never gained power. Thus, the executives were not convinced that O-rings would be a problem and went ahead with the launch.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Let's look at that data again, this time a different way. Let's relate temperature with O-ring failure on two axes. The oldest trick in the book, you can see a very simple relationship. The colder the temperature, the more likely the O-ring is to fail. You can see the lowest temperature that NASA had ever launched a shuttle at 53 degrees, having the only considerable damage to the O-rings. From here, we can plot a regression line to predict where the data is going, to get an estimate of what kind of damage could be expected on the day of the Challenger launch. On January 28, 1986, the weather forecast for Cape Canaveral, Florida was 26 degrees Fahrenheit. That's way over here. There were icicles on the shuttle. A simple glance at this would tell you that there's no way a launch could be authorized. Graphical excellence. A well-designed presentation of data made interesting and useful by substance, statistics, and design, communicated with clarity, precision, and efficiency. Graphical excellence gives the viewer the greatest number of ideas in the shortest time, in the smallest space, with the least amount of ink. It makes data useful, which gives the data power. Here are a few examples of simple, useful graphics that have become incredibly influential by following the principles of graphical excellence. Here we have Dr. John Snow's map of cholera cases in London, 1854. Before this map was created, it was believed that cholera spread through the air. This was before germ theory was established. Snow showed that the severe outbreak was limited to people who used a particular water pump to get their water. There was one anomaly, however. Employees of the Broad Street Brewery who lived very close to the pump did not get cholera. They were given a daily allowance of beer, so they didn't have to use the water pump. Health officials removed the handle to the water pump and the outbreak ended. From then on, it was known that cholera was transmitted through contaminated water. Here's a familiar image from the NASA website showing atmospheric carbon dioxide concentrations over the past 400,000 years. The reference line, handy arrows, and statement written across the graph makes this complicated data incredibly simple to understand. Atmospheric carbon dioxide is increasing at an unprecedented and scary rate. This data, coming originally from a study of ice core samples in Antarctica, has since been cited by 5,500 different studies in addition to being featured on the NASA website. It has no doubt affected public policy around the world. To examine the influence aesthetics have on the impression and ideas generated by a graphical representation of data, let's examine a few ways aesthetic presentation can bend meaning. In the following examples, you can see how aesthetic choices led to different interpretations of the same data. The following techniques are irresponsible examples of graphical representation. Graphical representations should follow the principles of graphical excellence. Technique number 1. Lying by omission. Here's the number of car accident-related deaths before and after stricter laws were enforced. It tells this story. Stricter traffic laws led to less deaths in Connecticut. This kind of graph is easy to understand. It communicates an idea almost immediately, but because it lacks context, the impression it gives can be misleading. When you add a few more points to the graph, or when a context is presented, the impression can change quite a bit. This is what the number of car accident deaths looked like in the years surrounding the change. You can see that decline in deaths from enforcing stricter laws is not so special. The same decline was experienced here, here, and here. This graphic tells a different story. Traffic laws may affect the number of deaths in Connecticut, but a decline like that may have been due to some other factor. You can see how a different context would have led to a different interpretation of the same data. For example, if the years preceding and following the change had deaths that looked like this, the original story would be reinforced. The impression of the graphic would be stronger. Selective omission, choosing to only present certain points, can lead to different impressions. If we just looked at the deaths in the years 1954 and 56, knowing a change of law occurred in 55, it would produce the impression that stricter laws led to more death. Technique number 2, blackboxing. Another aesthetic trick that is used to feign a more convincing dataset is to not make visibly clear the points where data was collected. This graph seems pretty trustworthy, but if there were only 4 points on it, the impression it gave would be less convincing. You could pretty easily detect an insignificant sample size, and in turn, the graph would seem less accurate. If the graph had a ton of points on it, it would seem more accurate. Refusing to put points on the line keeps the viewer from making an evaluation of trustworthiness. It puts the process of data collection in a black box that can only be made known from reading additional information about the procedure that might not even be available. Technique number 3, design variation implying data variation. Another aesthetic tool you can use to produce an untruthful impression of data is a design variation. Viewers could take for granted that the designs of similar-looking graphs are consistent. By changing the design of a graph or a few graphs placed in proximity, a false impression of the data can be delivered. Let's take a look at a graphic from a mining company's annual report. I'd like to focus your attention on the middle panel. That loss in parentheses is an accounting thing. When you chart net income, you put a little parentheses around numbers to denote loss. That in itself is an aesthetic choice that makes the fact that you're losing money obscured to people who don't know what it means. A negative sign would probably create a more accurate impression in those far outside the field. But whatever. What I'd like to point out here is the changing design of the graphic between panels. The bar graphs switch scales and then were placed so close to each other some people might think they're the same. Compare these two panels. That panel on the right looks like it's all tall bars. It's the net income. Nice tall bars make it seem like there's plenty of profit. But what if we added a reference line at net zero across both panels? You can see how it changes across panels. You can see a loss in 1970. In the middle panel, they made the low end of the bar equal to negative 4.2 million to give the impression of nice tall income bars across every year. Here's another example from the New York Times. They changed the design by just a hair in order to create a distinctly untruthful impression in the careless viewer. You can look at this graph for a good minute or two and not notice anything fishy. The scale doesn't change. There's plenty of non-data ink that makes it hard to compare things, but you can pretty much get it. 76 and 77 were good years for travel agents. 78 was a lot worse, it seems, but if you really squint, you can see that it says first half 78. The measurements taken were only for a half of that year. The design changes, but many people could miss that and see a pattern in the data that does not exist. In each of these examples, a new impression of the data is formed when a viewer misses a subtle change in the design. You can use aesthetics to bury that change in non-data ink nonsense, like this cross-hatching that camouflages the notation of a design change, or this dumb picture of miners on top of a toned background that gives way less contrast and visibility to the income loss. Graphical excellence can be a matter of integrity. Manipulating graphical representations can be used to create different impressions, like in these two charts showing the same national decline in GDP over the course of a few months, made more or less threatening by changing the scale, or these charts of religious populations, skewed toward different impressions by a simple 3D effect. When graphical representations are being used to form public policy or public opinion, aesthetics have come to have a great influence on how we understand ourselves and the world.